In this problem, we are asked to evaluate a trigonometric integral. And basically, a trigonometric integral is when you have a trig function raised to a certain power being multiplied by another trig function raised to another power. And that's exactly what we have here. And there are a couple of strategies depending on the exact scenario. And the thing you want to notice about this particular case is you've got sine and cosine being multiplied together. But specifically, the power of cosine is odd. And it turns out that if the power of cosine is odd, then we will follow the following strategy. The first thing we're going to do is save one cosine factor. So what that means is of the 5 factors of cosine, we're going to set one of them aside. Let's take a look at exactly what that would look like. So we'll have the integral of 8 sine squared of pi x. And then, again, of the 5 factors of cosine, you're just going to set one aside. So you're going to have the cosine of pi x. And then if you set 1 out of 5 factors aside, then there's still 4 more factors left over, of course. So you'll have cosine to the 4th of pi x dx. So that's the first thing that you would do. The next thing you would do is use a trigonometric identity. Now, we have to be a little careful here because it says that the cosine squared of x is equal to 1 minus sine squared of x. But if you look carefully at our setup, we don't actually have a cosine squared of x, at least not obviously. But watch what happens if we take this term right here and rewrite it accordingly. So we're going to take cosine of 4th of pi x and write it as cosine squared of pi x. And then that whole term would be squared. And the reason that that works, of course, is because when we raise a power to another power, we multiply those powers, and 2 times 2 would still give us the cosine to the 4th of pi x. So this is just a clever little way of rewriting the cosine to the 4th of pi x. We'll copy down the rest of what we have. And then we can use that identity. So we're going to replace the cosine squared with 1 minus sine squared of x. So this right here will be replaced with 1 minus sine squared. In this case, it's going to be 1 minus sine squared of pi x. So just make sure you do it that way. You'll have 1 minus sine squared of pi x. And then don't forget that this whole thing is still squared. We'll recopy the rest of the expression. And so far, so good. Let's scroll back up and see what the next maneuver is. You can kind of ignore all of this gobbledygook in the middle here and look at the bottom where it says you're going to go ahead and let u equal the sine of x. So the problem now turns into kind of a standard u substitution. In this case, we're going to let u equal not the sine of x, but in this case, the sine of pi x. They add that extra pi in here probably just to be a nuisance. Since this is a standard u sub, the next thing you'll do is you'll do the derivative. So we know that du would be the derivative of sine of pi x. Now, of course, the derivative of sine is cosine, so you'll have cosine of pi x, but then the chain rule requires us to multiply by the derivative of the inside. The derivative of pi x is just pi. So we'll include a factor of pi out front here, and then this is dx. My personal preference is to solve this for dx. So what I like to do here is divide both sides by pi cosine of pi x. And then by doing that, these will cancel out on the right-hand side. And then we can see that dx is equal to this expression right here. So just hold that in the back of your mind. And we go back to the original problem here, and we're going to make some substitutions now. So we will have the integral of 8. Now, here you have sine squared of pi x. Recall that that's the same thing as sine of pi x, all of which would be squared. We let u equal the sine of pi x, so this sine of pi x squared would just become u squared. So basically you'll have 8u squared, then the cosine of pi x, and then in this bracket here, you're going to have 1 minus, now same idea here, this sine squared of pi x, just like this sine squared of pi x, will just become u squared, like so. Don't forget that you still have the squaring outside of the bracket like that. And then you get to the dx. Remember, our dx, if we kind of clean this up a little bit, our dx we had solved for was du over pi cosine of pi x. Bit of a mouthful, but let's slide this over. And again, let's replace this dx right here with du over pi cosine of pi x. And what's really convenient here is this factor of cosine pi x and this similar factor or identical factor will cancel out. So we're left with that. And then if you really look carefully, you're going to have an 8 over pi. And when you have an 8 over pi constant, you can factor that out. So kind of a lot going on here, but we'll factor out the 8 over pi just to kind of clean up the integral. And then we're left with u squared, parentheses, 1 minus u squared, all of which is squared, du. There we have it, actually a simpler integral, but we have to simplify it before integrating. So to do that, we're going to take the 1 minus u squared squared and write it out twice, because whenever we square a quantity, we multiply it by itself. And then we'll multiply out the 1 minus u squared and the 1 minus u squared. So 1 times 1 is 1. 1 times u squared, actually 1 times negative u squared is negative u squared. Same thing in the middle, another negative u squared. And then negative u squared makes positive u to the fourth. We could actually combine these two in the middle. These are like terms, so that's just going to be minus 2u squared. Then we'll distribute this u squared into the parentheses. So finally, you have u squared minus 2u to the fourth plus u to the sixth du. We are prepared now to integrate. So we'll have the 8 over pi in front. We'll follow standard integration rules. So u squared becomes u cubed over 3 minus 2u to the fifth over 5 plus u to the seventh over 7 and then plus c. Remember that to integrate u to the power of n, it's just u to the power of n plus 1 over n plus 1, just as a little reminder there. And then it seems like we're done, but don't forget that all of these u's right here were equal to sine of x. That was our original substitution. Excuse me, they're equal to sine of pi x. I'm glad I looked back there. So these are all sine of pi x's. Let's replace each one with a sine of pi x. And there we have the answer. Just notice the way in which we wrote that. We replaced the u's with sine of pi x's, but the first one was cubed, so we actually had to write it as sine cubed of pi x. The second one was raised to the power of 5, so we wrote that as sine to the power of 5 of pi x. And then the third one was raised to the power of 7, so that was sine raised to the power of 7 of pi x. So just be careful about how those are written, but there is the final answer.